Alrighty. Hey, everyone. Good afternoon, good morning, good evening, from whichever part of the world you're joining from. We are just waiting for more people to join in. So stand by, everyone. We'll be starting in the next 3 minutes. Nice t-shirt, by the way. I like your t-shirt, Bryce.
Yeah, I was hoping someone would.
Sweet. We have 15 folks with us already. We have few people coming in as well. Cool. We can go live in the next 1 minute.
All right.
Just admitting a few more people to the call. Thanks everyone for joining in. Got it. I see a few more people joining the call. Just a moment, I'll just let them. All right. I think we can just kick off. Hey everyone, and welcome to the Superhack workshop titled Attestation Masterclass. Joining us today is Bryce, who will be taking us through this session. And with that, I'll pass it over to Bryce to get the workshop started. Over to you, Bryce.
Thank you, Calvin, so much. Hey, good morning, good afternoon, good evening to everyone. This is a masterclass on attestations. We're going to focus on EAS to understand what it is and how you can start building super fast. We'll get into a couple technical things, but if you do have a question as we go through this, let's make this interactive. So feel free to drop some questions into the chat or just raise your hands and we'll get started. So the flow that we're going to go through is why EAS exists. I think it's a really important primer to really understand like why attestations matter, because then it'll really help you understand like how attestations might be able to be applied to your hack. We'll talk about how to actually build with EAS and some tips that we've kind of picked up working with other hackers throughout the past ETH Globals, as well as just working with builders more regularly. And then we'll talk about some of the ideas that you can actually build for the Superhack and then some resources to get you started. Quick intro on me. I'm one of the core contributors for EAS. I lead all product operations, marketing. I help builders all day, every day. That's our primary focus right now. So you've probably seen me in the Telegram group and some other areas, but feel free to reach out to me if you ever have any questions after this call. So let's start. How do we actually decentralize more than just money and assets? When Vitalik first launched or announced Ethereum over 10 years ago, there was all these grand visions to decentralize the world. How do we, create land registries and voting systems and all these things that are really amazing blockchain use cases, but we haven't really been able to, realize them yet. And why is that the case? Well, it's really not easy for builders and people to go from this idea of a smart contract into building a land registry, because you'd have to build so many different individual siloed components. And at the root of all this is like, how do we actually build more trust online and on chain? And how do we actually know like who to trust if a land registry was created? And so something was missing. And that was really the start for how EAS started to come to life. And the who is really the hardest part, right? If you want to trust someone, usually there's a person or an entity or a thing behind it that you have some level of trust in, and it's based off an identity and your relative reputation to it. But this whole concept of identity is like so abstract, and the identity ecosystem itself is so fragmented. And it made us think, well, maybe everyone's building one layer too high, and there's a primitive that's missing. So we did this thought experiment, and we were thinking, well, what actually was your first identity? At what point in your life you didn't have an identity and then you did? So there's like some moment, something that happened. And so we realized you could actually reduce it down to when your parents name you, right? They attested to your name. They said, this is my son, Bryce. And then the doctor attests to your date of birth and the government attests to passport, your identity card, you go to school, the teacher attests your grades, but you also make attestations. You attest to people that you trust, you attest to things that you like, right? People attest to your skills once you get a job. And all these different micro interactions and these intents between entities saying things about each other are simply just attestations. And an identity and a reputation can be represented as this aggregate of attestations. It's the story over time. But we also need to be able to trust the things that we interact with. So it's not just the who, but I'm sure we're all very skeptical of random links, right? In any of the chat groups that we're in, email, spam emails, content we're consuming online. It's only getting worse with like all the misinformation and AI generated content. The communities we join, how do we actually know who to trust in those communities? The products we buy, like how do we know 5,000 reviews are actually good reviews or not? And so we were thinking there's this primitive that's missing, and it really boils down to these attestations. Attestations are simply just digital signatures on structured pieces of data. So the way that EAS works at its highest level is you register a schema, which we'll go into more detail, but it's the data structure of the attestation. And then the other smart contract allows you to make attestations with it. There's some other cool utilities we'll talk about, like resolver contracts, reference attestations, and other things. But the core concept is you register a schema or use an existing one and then make attestations with it. EAS is a public good for doing this. And you can make attestations on-chain or off-chain. And more notably for the Superhack, EAS has been natively integrated into the OP stack. So if you go onto the base docs or the OP docs, you'll see EAS in the core contracts list, linked by 2 pre-deploy addresses, so ending in 21 and 20. And so you can start quickly building with EAS. So anytime a new super chain gets deployed, it automatically has the 2 EAS contracts as part of it for registering a schema and then making attestations. Over 1 million attestations have been made in the superchain since deploying last year. So we've had over 14,000 unique attesters. There's been over 1,000 different types of schemas registered and over 540,000 recipients that have received attestations. So some notable entities that are making attestations: Coinbase launched their Coinbase verifications product that uses EAS attestations. You can see that on Base. The OP Foundation uses EAS to attest to like badge holders and other retro PGF data. Gitcoin Passport attests to the scores and stamps on chain. Devfolio from the on-chain summer build-a-thon, if you participated in that, they created a quadratic voting system using EAS. And then there's some fun projects like receipts for attesting to like your Strava activity data, so the mileage that you've ran or bicycle or cycled. Click for an Oracle service, and then a really cool one, ETH Global. If you attended Brussels, you might have seen Kartik on stage. He was talking about moving a lot of the on-chain interactions, and EAS is going to help to power some of that. So all of these attestations as a primitive to being able to build more trust between different interactions. Question in the chat, yes, definitely can give you links to the projects we just talked about. There's actually an ecosystem page on EAS's website that will link out to it, but we'll post that in here. So some of the use cases that these attestations can really help build more trustful interactions between entities. And so you can build verifiable voting systems, marketplaces. If you think about like, hey, what if I did like proof of provenance or proof of funds or anything like that, proof of attendance, these are simply just attestations. The registries, any sort of registry where you want some sort of verified source saying this is like a true member, registries are great use cases. Any sort of interaction between two entities where a digital signature signing that piece of data will add more trust to that data and where people can rely on it is a great use case for attestations. So let's get into the meat. We're going to talk about how to actually build with EAS. So we'll cover a few topics: registering schemas, making and revoking attestations, the composability, which is an important part that can get overlooked, resolver contracts, and then also delegation. So schemas are the building blocks of attestations. So once again, it's that data structure. And when you're thinking about like your product and your project, it's really important to think about the user flow of what your project is actually like, who you're building for and the experience that they're going to go through. Because then you can really think about what attestations or what interactions would benefit from being more trustful. And it'll also help you think in a more composable way. So instead of just creating a schema for one specific area, there might be a few attestations that make sense to build together. They're really easy to register on chain. So in the Superhack, if you go to Optimism or Base on the site, and I'm going to actually slide over to the Explorer website. So this is an example Explorer on Base, but it's also live on Optimism and Acello and a couple other super chains. And so when you make attestations, if they are made on chain, we'll index it and then display it on the Explorer here. And so we can see that there's 600,000 attestations. You can see some coming in a few seconds ago from verifications.coinbase.eth using a schema. And we'll go into some of this, but let's talk about how to register a schema. You can do this through code, but we did build some no-code tools so you can easily register schemas more quickly. So I'm on the schemas page, and schemas, as you can see, you can register them about pretty much anything. So here's someone registering a schema for NFT metadata, IFPS CIDs, a train ticket number, invalid till, a bus ticket number. But you can register a schema about any sort of content. And so we'll actually create one. And we're actually going to create a schema for just being based. So if we wanted to attest to someone being based, we could create a schema. First, we'd want to see if a schema exists for based. I don't think it does. But you can use the search tool. So there's some things for like is true, but nothing for based. So we can name our fields. And then we can select the field type. So these are all address string, bool, bytes, uints. You can select whatever choice is best for the field. So we'll just do based as a true false field. We can add more fields, but we don't need to for this use case. And then we can also add a resolver address. And when you register a schema, resolvers basically give the schema a superpower. So it can be any smart contract logic applied to the schema. And we'll go into more detail, but essentially you can create ways to prevent people from making attestations. You can mint an NFT after an attestation is made. You can require like different conditions before the attestation is made. A lot of control over the logic. So we'll create the schema. And I set the revocability to true. So this means that I want the attestation to be revocable or allow people to be able to revoke the attestation if they issued it. You could create a schema where all attestations are irrevocable, meaning no one can ever revoke it. Most commonly, most people set the field to is revocable to true. So we just made this schema, and I actually did this on Base. And so we registered this. Every schema has a UID to be able to reference it more easily. And then we can see bool is based, right? Or just based. And if we, now that the schema has been registered, we can make attestations with it. When a schema is registered, we did add a section for a code sample. And this allows you to easily see using the EAS SDK, how to make attestations with that schema that you just registered. So it'll pull in the contract address for the chain, the schema UID that we just generated, and then you can see kind of how it all flows to actually make the actual attestation. So it should help you build a little bit faster. When you make an attestation, you can do this on-chain or off-chain. And attestations, they don't always require a recipient. So if I were to just make a statement about something, it might not be about someone or something. So I won't need a recipient, but in this case I can. So we'll just attest to Vitalik being based. So we add a recipient. bool, false, or true, right, for based. And then on the attestation itself, attestations can have an expiration time. So if you wanted to create some sort of access control system or any sort of like registry where someone needs to like re-verify, you can set an expiration time on the attestation. And then attestations can also reference, and we'll show a good example here in a second about that. But you can make attestations on-chain or off-chain. I'll do this one on-chain. Actually, who in the crowd has an address that they want me to use? Does anyone have a .eth address where you want me to attest to you being based? All right, we'll use Vitalik. And it's all relative, right? Like the value of the attestation is who's the attester. So I'm not an authority to attest to people being based, right? Like I could, but it's my relative reputation to those looking at the attestation. Perhaps if like Jesse or someone from the base team attested to someone being based, then that would hold more weight. But as these attestations get generated, you can start to build relative reputation graphs of like how, what it actually, the level of importance that it might have. And so now that the attestation has been registered on chain, we can see the created dates from to the address, the schema that was used, bool based true, the transaction ID on base scan. And because that was the issue of the attestation, I can revoke the attestation. So if anything changes to the state, could be good or bad, right? Let's just say for whatever reason, I don't want to keep this attestation as a valid attestation anymore. I can simply revoke it. And it will revoke the attestation so people can know whether or not that data is still valid. And so it's revoking right now. I'm looking at the questions. If anyone has them, feel free to drop them in. So we can see the attestation has been revoked. And then if we go to the Explorer, we can see here's my attestation that I made with 363 a minute ago. And if I were to click on it, paste, cool. So we made that sample schema for being based, right? Very simple to create it using the no code tools, or you can do this all through code using our SDK. Now, one thing we didn't talk about is composability and the efficiency of it. So when you register an attestation, they're highly composable and it'll allow you to save gas and also provide more context to different attestations. So I'm going to go through an example of, we built a sample website called Speaketh. Okay, this is just a simple example demo site. But it allows you to make an attestation as a statement. So if you think about a social media website, when you say something, you're simply just attesting to the statement. So I said, excited for the Superhack 2024. And then there's a comment on here for lots of prizes available. And then there's also 2 likes, right? So if I were to go to this attestation record, we can see that the attestation schema that was used was post, which is just a string post. And it said, excited for the Superhack. It was signed by bryceallen.eth. And then there's 3 referencing attestations to this one. So there's a post and 2 likes. And so here's the post, 2 likes, and then here's like the reply post. And so attestations, what they can do is they can reference the UID of an attestation to build them in a more composable way. So if I were to click on this like an entity, this address attested bool like true, and it's referencing an attestation UID. So I can click reference attestation, go back, and then we can see excited for the Superhack. So the resolver contracts really allow you to be able to control who can attest, trigger payments, mint an NFT, charge for an attestation. So you can create a profitable way to actually, if you have a brand that has some authority, those brands can start charging for the attestation to be generated. You can enforce who can receive attestations. You can enforce expiration dates. Any smart contract logic can be applied as a resolver contract, and that gets attached to the schema itself. So deciding between on-chain and off-chain, off-chain attestations still have the authenticity of the digital signature. The one thing that they don't have is a verifiable timestamp because it's off-chain. There's no consensus from the network saying that the attestation occurred. However, we did build tooling that allows you to timestamp the UID on-chain. So with off-chain attestations, you can store them anywhere, IPFS, locally. It can still be verified by a smart contract. It uses EIP 712, but it does take, it's more computationally intensive versus just having it on-chain. So if you want a smart contract to verify and kind of interact with an attestation, generally it's better to go on-chain, but then you just want to make sure that you're privacy first, as like anything you put on-chain is immutable. And then, so on-chain data is more public, off-chain data is private by default, you have more control. And off-chain is free. So it's just a digital signature using your Ethereum wallet. So off-chain attestations are private by default. If you scan this QR code, we can actually make one really quick just so you can see it. We'll do this super fast. 1 second. All right. While I'm signing in really quick, I'm going to read some of the questions. So is it for verifying anything like documented use in social accounts? So only there was a question about revocations and who can actually be the revoker. The person that makes the attestation is the only one that can actually revoke the attestation. So you can't create a schema that would allow someone else to revoke the attestation, but you could have a scheme where, you attest to something no longer being valid, or if the actual, maybe it's a server that's actually creating the attestations for people and you're, revoking them on behalf of others. But generally you would need the attester, the address that actually signed the attestation, to be the revoker. And you could just display it on, yeah, exactly. You could display it on the front end. Okay, so I'm going to make an off-chain attestation really quick just for a statement. So we'll just look for string messages, totally fine, just so you guys can see how off-chain attestations work. We're not going to use the recipient, but we're just going to say this is off-chain, no expiration date or anything like that. But it's requiring, if you can still see my screen, it's an EIP 712 type signature. So I'll just sign it. There's no gas. It's pretty instant. And now you can see that this attestation has been made. It gets its UID. It was signed by this address. There's the created timestamp, but there's no verified timestamp on chain. So I could timestamp the UID on chain. And this can be stored wherever. It can be stored locally, and we can publish it to IPFS and then pin it to the EAS Explorer. You could pass it around as QR codes. So if you scan this, you can see how it gets decoded in the browser. But it's actually not stored anywhere right now. So it's encoded in the URI fragment of the URL. So you can see this super long URL up here. So it's actually just passed through the browser. And then you can decide where you want to store it. So EAS itself has no idea that this exists. Once it's published, we do have GraphQL endpoints that allow you to query any attestation data. So if you go to base.easscan.org/GraphQL, or if you're on Optimism, same thing, you'll hit the API so you can query the data. There's some really cool utilities for attesting to Merkleized private data. So being able to attest to like any amount of private information and then selectively reveal data against the Merkle root. It's available in the SDK, and it's a pretty powerful tool. So it uses this schema called private data. And so if I had, it'll allow you to generate a proof of the Merkle leaf, right? One leaf of the entire Merkle tree. And then you paste that in and you can verify that the data was actually a part of the Merkle root that was signed. If we have some time, I can go through that, but just in the spirit of like talking about some of the ideas and stuff, we'll move forward. So the Superhack ideas, so we're really excited about the potential of what attestations can build. We've had amazing traction so far, but we're really passionate about making sure that attestations can help us bridge from our online, and on-chain world, our on-chain to online worlds, and really showing people how blockchains have like more utility and purpose beyond, financial speculation. And so real world use cases is the focus for us, as well as developer tools. So one of our mantras for the year is help builders build faster. And so we want to see what tools people can create that will help other attestation builders build. So the prizes that we have for this hackathon, the top 3 real world use cases will be awarded. And so just some general ideas of what that could look like. You could create a voting system using ZK and attestations, a notary service attesting to the provenance of intellectual property, any sort of registry. So like you can imagine like a land registry, a business registry for any like public data, authenticating published content. So being able for a signer to attest to the authenticity of their generated content, privacy preserving healthcare attestations, on-chain commerce. You can imagine like a receipt after a transaction occurs that there's like an attestation of what the products were. And the list goes on. There's a lot of potential, and we've already seen some of these use cases built in previous hackathons. So excited to see people be intentional about what's possible here. And then the second one is best attestation developer tool. So some ideas that you could build: React components for attestations, like building small components that allow people to make or view attestations. And you could add that into the on-chain storage or the on-chain kit as an idea. Storage for off-chain attestations, so creating an easy way for people to manage their off-chain signed attestations. Analytic tools. It would be awesome to see like an AI agent that gets trained on EAS data for additional DevRel support. ZK attestation utilities, allowing people to generate an attestation off of some specific schemas, or a zero knowledge proof. But anything, utilities for Farcaster frames, anything that helps builders build with attestations, we'd love to see some of those ideas, and would love to help kind of promote that for you. So some additional resources, everything. So the contracts are open source. There's helper contracts that are in the repo. There's the Attestation Explorer, the GraphQL API. There's the indexer is open source, so you can index your own attestations. And then there's hundreds of open source projects that have been built with EAS. We're happy to share some examples if you need some help. And then some recommended repos to take note of: the indexing service, contracts example, the SDK is open source, a lot of good stuff in there. And then we built some example apps. So how to make server-side attestations. We built this app called Is True that just allows you to attest to it has a bot that actually attests to the authenticity of a statement. Met IRL for off-chain attestations just shows you how to generate off-chain attestations and how to pin them. And then we built like a rock, paper, scissors app that allows you to have like a commitment scheme to verify game moves. So for who attested to rock, who attested to paper, and then being able to reveal it and determine who the winner is without disclosing it beforehand. There's a lot of online content too. So tons of videos. We've invested a lot of time into the docs, but if you guys need help, just let us know. So I'll pause here. Yeah, I can talk about, so there's a question about the private data attestation. So EAS itself, the protocol is very elegant and simple, but we've been extending the functionality with it. And so on top of the protocol, so the scheme is called private data. You can find it on Base, you can find it on a lot of different chains, but private data, it's simply just a private data bytes 32 field. And so we created it and we extended the UI to be able to Merkleize any sort of private information. So we can do like, I don't know, name, Bryce, we can do like bool, maybe it's like license, license, and then, I don't know, some license number, address, whatever, email, right? And then it can be any fields, but I'm just going to keep this simple. And then we can do this on chain or off chain. I'll do this one on chain so you can see. So we're signing the on-chain transaction, and what happens once it actually gets attested, and you can do this all through code, right? You don't have to use this front end, but it's Merkleizing each of these fields into a private, into a Merkle leaf, right? Each one of these is a leaf, and then there's a Merkle root that gets generated, and that Merkle root is what's being attested to. And so on my screen here, you can see that I can see the private data fields, but there's the Merkle root that was attested to. And so if I were to open up a incognito window, and I were to grab this same attestation, we can see that I don't see that private data in here, right? But I can generate, let's just say I want to be able to prove to someone that my name is Bryce and my email is this, but I don't want them to know my license or my address information. I can generate a proof. It generates each of the leaves that's salted as well, so you can't brute force it or guess it. And then I can paste the proof in. Oops, there's proof result in there. And then verify the proof. And then it instantly decodes, and you can prove that it actually was a piece of it. So if I were to change this, it wouldn't verify. Or you will see that it's not invalid proof. But that allows you to attest to any sort of private data, and then if people have the Merkle leaf, they can verify that the data was actually a part of that Merkle root. So we just extended the utility on the front end to be able to decode that information, but pretty powerful, a lot faster than a zero knowledge proof, not as private as a zero knowledge proof, as you still have to provide the leaf, but a lot of use cases can be built with the private data attestations. All right, so how are we doing on time, Calvin?
Yeah, I think we're doing pretty much right on time. So yeah, I think, do you want to open the floor for some questions and answers? I can see some questions on the chat box. If you want to go through that, that would be great.
Yeah, hold on, let me see if I can read through these. How would you go about attesting against provenance, i.e. data coming from an IP address? Would it work in a similar way to this private data example? Not sure if I fully understand the use case behind that. But attestations can be generated server side, so you can have a server generate the attestation. The IP address, Liam, if you could describe what you're hoping to get out of that or the example. So for this, do you need to store the proof locally for the private data? Yeah, so the Merkle leaf data would need to be stored somewhere. So it would need to be stored locally. And then, so you can imagine like the user, if they get the attested data and they're provided their Merkle leaf, they can keep that, or you could just keep that like locally on a phone or wherever, and then allow people to selectively disclose that when needed. Yeah, so the attestation, if you want to actually prove, so the question was for using IP as like the proof of origin, the value of the attestation at its core comes from who actually signs the attestation itself, right? So if you trust, a specific entity, let's say you're going to trust Coinbase, right? Because they have a good brand authority, then you might trust their attestations. But if you don't if Coinbase isn't signing in someone else's, you could still trust that data, but it's really up to you. We've seen some people use generating attestations from a TLS signature. So if they're like logged into some sort of site, generate a proof and signing the attestation that it came from the signature. But really the value of the attestation comes from who the signer is and their relative reputation to you, and if you care about who that signer is or not. EAS doesn't do the verification of if you should trust an entity or not. So can you store the private data proof anywhere you want, and you can allow other users to share it with whomever and however they want? Yeah, so you can store the proof, the private data proof, the leafs, wherever you want, and you can allow users to share it with whomever. And you could obviously build some protections around, like, sharing some of that information and keeping it more secure. But it's a simple way to be able to just selectively share a leaf against a Merkle root to keep some of that information more private. Any questions about the hackathon or any of the tooling that we went through? Doesn't seem like it.
Cool. Any questions for Bryce? Feel free to drop it on the chat box or probably raise your hands. You can also unmute yourself. All right. I think we have received one from Lando. Are we able to combine both tracks? I believe he's asking, would he be applied for both the tracks after project submission?
Yeah, it would be a really unique use case. If it's a developer tool for a real world use case, yeah, I don't see why, like, as long as the quality is there. I would say it's probably going to be more difficult to be awarded for both. But I wouldn't say it's not possible. If there's a really good developer tool for a real world use case, I think that's an interesting approach. But it might skew more towards the developer tool award, in my opinion, compared to someone who builds a real world use case.
Sweet. All right. I think we can wrap up here, Bryce. Thank you so much for joining us today, Bryce, and for the great presentation.
Yeah,
Big, yeah.
I was gonna say thank you guys very much for the time, and we are very accessible. Jump into the Telegram group or drop questions into the ETH Global Discord. We'll be watching it. Happy to help anyone builds and think through their ideas or troubleshoot through integrations, anything that would be helpful.
Sure. I think Lando has raised his hand. Do you want to take that up, Bryce?
Sure.
Lando, do
Yeah,
you want to
hi
unmute it?
Bryce. Hi, just had one quick question, follow-up question.
Yeah.
Um, okay, is there for the private data, because this seems very interesting, right? So is there a limit on the, sorry, two questions. Is there a limit on the amount of private data attestations you can make? And is there like a limit on the fields that you can expose or are able or are a part of the attestation and you can reveal or hide?
So I'll answer it in two ways. So from like the only limitation on an attestation being attested to is just literally the block size. So you can have a schema that has like 1 million fields, but I would argue that simpler is usually better for the schema structure itself. For the private data, the Merkle tree, it's an infinite amount of data can be Merkleized and then, kind of selectively revealed. So there's no limitation there. When you attach to things on chain, the only limitation would be the block size.
Okay, I get it. So there's no for the on-chain attestations, is the blockchain the limit, but off-chain, I guess there's no limit on the speed and the amount for off-chain attestations.
Correct.
Okay, thank you.
Correct.
Sorry. You mentioned that two ways. For the off-chain attestations, you can do some on-chain stuff. You mentioned a special address that like verifies the attestation, and it's more. You said it's more computational, more heavy than just putting it on chain. Could you just explain that a bit?
Yeah. So with an off-chain attestation, it's not on-chain, so it just requires more work for a smart contract to verify the signature and everything versus having it readily available already on-chain. And so off-chain attestations, they can still be read by a smart contract. It just takes more work for the smart contract to verify it. So it's just a trade-off. Like you can do so many unique things with off-chain attestations. Generally speaking, if you want a smart contract to interact with the attestation, then it's better to figure out how to do it on-chain, but it's still possible off-chain.
Okay, thank you. And that just sorry to take too much of your time. This private data you mentioned, can that also applies to this like a smart contract doing stuff with it when it's off chain, like you just explained, for the private attestation data?
Yeah, so inside, if you go to our docs page and you go to the EAS SDK, you can see there's a using the private data class section inside the SDK itself. And so it'll walk you through how to verify the proofs, making them, etc. But just right inside the main EAS repo inside the SDK, and then just down to the using the private data class, it'll kind of walk you through how to create it and verify it.
Okay, thank you so much. Sorry to take up so much time.
You're good, man. I hope you built something.
Yeah. I mean, we've been playing with EAS for some time, and private. I had a hard time understanding the private data part, so you really like opened my eyes just in this small call. So I'm gonna look into that really deeply.
That's awesome. Yeah, feel free to reach out if you have any questions after. Just join the group, yeah, or post it in Discord.
Cool. Thanks, Lando. Thanks, Bryce. Thanks again, Bryce, for joining us today and for the great presentation. Big thanks to everyone for joining in the first workshop for Superhack from different parts of the world. We have one more workshop scheduled for today in the later half of the day. As Bryce mentioned, feel free to connect with Bryce in the partner channel on Discord if you have any questions, and they shall get back to you. Cheers, everyone, and